Hi and welcome. I hope everyone is okay. Now, in this lesson, we will pass the new chapter. Our chapter is 5. It's called sampling. Now, we can start. Why do we study sampling? Uh, in our study of statistics so far, work has focused on information collected from from a population. Population refers to the complete collection of items of interest. It can be as diverse as a population of people, or a population of fish, or a population of lead lights. Population of fish, population of lead lights, or population of people. A sample is part of a population. A sample can be small or large. For example, Genie has a collection of 2,984 bottles. Uh, the whole population is the 2,984 bottles. We may want to investigate the average size of the buttons in Genie's collection. Measuring the button size of anything fewer than 2,984 buttons, whether it is 10 buttons or 100 buttons or 1,000 buttons, is to collect information from a sample of the population. Okay, you may think it is preferable to make decisions based on all possible data, but it is only in limited circumstances that a complete data set is sought. Data data can be collected from the whole population. Census data is an example. The data can be collected from the whole population. Census data is an example. A government census collects a complete set of data from every member of the population about all aspects of life to monitor demographic and lifestyle changes. This enables the government to plan for the future needs of the population for housing, education, health, so on. Census data are expensive. Census data are expensive and time consuming to collect, process, and analyze. While it is true that the more information you know, the more reliable your conclusion. There are reasons why we prefer to use sample data. We have some example about why we prefer to use sample data. It is less expensive as fewer resources are needed to gather the data. There will be fewer recording errors as there is a smaller amount of data to process. It takes less time to collect and analyze the data. It is more practical as fewer items or data are needed. Okay, why we prefer use sample data and or sampling. The large sets of data are more reliable than small sets of data. A reasonably large sample chosen at random from a large population will generally be representative of the characteristics of the population. These two statements allow you to make valid conclusions from a sample of data. They form the basis of the central limit theorem. And we will learn central limit theorem next lesson. To address the question of how reliable parameters such as the mean of sample are as an estimate of the mean of the whole population, it is necessary to consider the nature of the sample, how representative it is of the whole population, the size of sample, and the variability of the population data, the size of the sample and the variability of the population data. Introduction of sampling. The best possible sample should have all the characteristics of the whole population. Ideally, it should have properties and characteristics identical to those of the whole population. But this is almost impossible to achieve. If one or more characteristics of a population are over or underrepresented, then you may introduce bias. If bias occurs, then one or more parts of the population are favored over others, making the sample unrepresentative. A population is the complete set of items of interest. A sample is part of a population. A sample should be representative of the population. A sampling technique that results an unrepresentative sample is said to be biased. A sample technique that results in an unrepresentative sample is said to be biased. Okay, and use of random numbers. A random sample gives every member of the population the same chance of being selected. The complete list of all items or people in the population is the sampling frame. For a small population, the method of generating a random sample could be as basic as giving every member of the population a number, placing numbered discs in a box, and choosing discs at random. Random is very important, and the samples sample is representative of all population. You can always generate a random sample regardless of population size using random numbers. And then Microsoft Excel has a function to produce random numbers. The following process, Microsoft Excel has a function to produce random numbers. I want to show that in Microsoft Excel we can create or we can produce random numbers. Our formula in Microsoft Excel, I want to show that our formula like this, and according to this formula we will produce the random numbers. According to this formula we will produce the random numbers. Okay, now we can use the random Microsoft Excel. Excuse me that 1 minute. Okay, now it's here. We have a formula about produce the random numbers, and for example if we want to if we want to produce the numbers, random numbers, between 0 and 1, 0 and 1, we should use the this formula. Random number, we will produce the random numbers, but the numbers are between 0 and 0 and 1. Okay, now in Excel, Microsoft Excel, I am producing the random numbers, random shortly, and then copy these formula, produce the random numbers, produce these numbers randomly, and in Excel. If I want to produce the numbers, the numbers become the whole numbers, so I should use different formula. This formula, if I want to produce the random whole numbers, this formula is like this: in int, and then brackets, and 250 multiply random plus 1, and bracket, and then I want to produce, I produce the random whole numbers randomly. For example, these numbers randomly, but these numbers are whole numbers. For example, one more time, and equals int, then 250 multiply random and plus 1 and bracket, and then copy this formula for example column, and this number is random whole number. For example, I can create more number, this, or create this section, for example, yes, and created more numbers, this section, for example, and I can create the random whole numbers, how I want to many numbers. Okay, and the Microsoft Excel can create or produce a random whole number, or the numbers are between 0 and 1. If I want to produce random numbers are between 0 and 1, I should write this formula: random brackets, and then these numbers are between 0 and 1. But if I want to produce the random whole random number, our formula is int bracket 250 multiply and random brackets plus 1 and bracket and copy the column, this column, or more time. Okay, these please notice that these numbers these numbers are produced randomly. Okay, and how we can use the randomly the random these numbers, and why we can use why should we use the randomly numbers. Okay, the following process outlines one way to use a table of random numbers to find a random sample. Suppose you want to choose a sample 20 people from a population of 500. First, number each person from 0 to 499. Next, decide on a starting point in the table of random numbers such as the one following. Okay? For example, we can decide starting at the top of the second column and reading the first 3 digits of each set of 5 digits, going on the column produce the following list. This table, starting at the top of the second column and reading the first 3 digits. First 3 digits, 253, 353, 365, 801, 353, 365, 801, and then 285, 221, 223, and 85, for example, like this. And then 285, 732. But please notice that we have more time, 285. So this number shows us a person. So these numbers the same, also the person the same. So if we come across to the same number, for example, the number 285 appears more than once, so it is ignored the second time and any subsequent times it appears. One way to deal with numbers greater than 499 is to ignore them. If we come across to 285 numbers more than once, it is ignored the second time. So we write these numbers, and we came across the 285 more than one, so we ignored this number, and we should go on the same. Okay, one way to deal with numbers greater than 499 is to ignore them. For example, you can come across to 732, but you have 500 people, 500 population. So if you come across to the 732, you can ignore this section. For example, if you come across to the 988, you can ignore these number, and you can go on what you state there. Okay, and then uh, other way, you can move on the next random number until 20 have been selected. Alternatively, in this example of a population of 500, 500 could be subtracted from each number over 499, and the new value used as the random number. For example, when you come across to the number of 732, so minus 500, and you can use 232. If you come across to the 988, so you can use 988 minus 500, 488. For example, if you come across to the 817, so you can use minus 500, 317. Okay, this is other way. This is other way. If you want these number ignored, if you want these number subtract these number minus 500. Okay, we could start at any place. We could start at any place in the table and read across rows or down columns. Although the random numbers in this table are in blocks of 5 digits, with 5 blocks in each cell of the table, this is simply to make it easier for you to keep track when using them. The digits can be used as if they had been written in one long continuous line. When you reach the end of the row or column, and need more values, you simply move to the next row or column respectively. Okay, and this is very important, these sentence. Random numbers can be used to generate a sample in which you have no control over the selection. However, bear in mind that using a random sampling method doesn't guarantee that the resulting sample will be representative of the whole population. Doesn't guarantee, but this application is very useful for sampling and for sampling about all population. Okay, and we have an example about this table, and now for it uses the random number table from earlier in this chapter to identify the first four two digits. The first four two digit random numbers. For it uses the random number table from earlier in this chapter, this table earlier example, to identify the first four two-digit random numbers, starting at the top of the second column and using only that column. Explain how for it obtains each of the following sets of random numbers. Okay, now we have 35, 33, 30, 53 and 65. We are finding for it how for it is starting at the top of the second column, and how for it obtains each of the following sets of the numbers. Okay, I want to copy paste the second column uh, for looking at easily. Okay, and now we will explain how for it obtains each numbers. Okay, now the for it 35 here, 35, 35, 33, please notice that 53, 53 and 65, and also for it decide to choose these numbers, so for it can use to can choose these section. The other one 35, 36, 80 and 28. Okay, 35, 36, 80, 28, and for it also can choose these number, and these number these number is instead of the person, any person, some person. For example, the other one 33, 82, 22 and 2. Okay, 33, 82, it's very hard, I think, 22 and 2. Okay, please notice that 33, 82, 22, 22 and 2 and 2. Okay, and for it can decide to choose what he wants, decide to choose these from the these table. Okay, now we in this lesson we had learned an introduction of sampling, and the other lesson we will pass central limit theorem, very important about the sampling, and then have a good lesson and have a good day.